Welcome back to factoring using the try method. If you haven't seen our first video, check out the link in the description below to learn how to use the try method before watching this video. Now that you've had some practice factoring, you're now ready to factor quadratic expressions where a does not equal 1. Looking at the first example, let's factor 5x squared plus 23x plus 24. Remember that the first step is to factor out the GCF, so let's find our GCF. Looking at 5, 23, and 24, we see that the GCF is 1. Now we are ready to find the factors of a. What are the factors of 5? 1 and 5. Now let's find the factors of c. What are the factors of 24? 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Our positive constant of 24 tells us that we need a sum of our b value, which is 23. You've practiced factoring when the factors of a were always 1 times 1. Now we're going to see that our factors of a could be many things. Let's see how that looks. As we start looking for the right combination of a and c factors, remember we are looking for a sum of 23. If we take 1 times 1, we get 1. And 5 times 24 is a number greater than the sum of 23, so even without doing that calculation, we can see that this is not the combination we want. Now because a is not 1, we have another combination to check. Looking at the same pair, we could multiply those numbers in a different way. If we took 1 times 24, we get 24, and 5 times 1 is 5. The sum of 24 and 5 is 29, so that's not the pair we want. Continuing down the list, 1 times 2 is 2. 5 times 12 is 60. The sum of 2 and 60 is 62, which is not what we need. 1 times 12 is 12, and 5 times 2 is 10. The sum of 12 and 10 is 22. Not quite there yet. 1 times 3 is 3. 5 times 8 is 40. The sum of 3 and 40 is too large. 1 times 8 is 8. 5 times 3 is 15. The sum of 8 and 15 is 23. That's the pair we need. So we're going to draw some connecting lines between the 1 and 8 and between the 5 and 3 to indicate how those numbers need to be multiplied together to get a sum of 23. Now we're going to write the two factors, so let's draw two sets of parentheses to fill in. Use the factors of a to write coefficients for each x. So we would have 1x and 5x. If we want the 5 and 3 to multiply, let's think about how we expand or FOIL binomials. Then the 3 should not be in the same set of parentheses as the 5. Similarly, if we want the 1 and 8 to multiply, then they should be in different sets of parentheses. Now we'll put in our operations. We are looking for a sum, so our signs will be the same. Where do we look to determine which sign to use? Right, we look at b. b is positive 23, so both factors get a plus sign. The factors of 5x squared plus 23x plus 24 are the quantities of x plus 3 and 5x plus 8. Looking at another example, we have 12x squared plus 51x minus 45. What is the first step? Find the GCF, which is 3. Now let's factor 3 out by writing 3 in the front and an open set of parentheses. 3 times what would result in our original problem? 4x squared plus 17x minus 15. Now only looking inside of the parentheses, what are the factors of a? 1 times 4 and 2 times 2. Here we see that our list of factors of a is a little longer. That's okay, our process isn't going to change. What are the factors of c? 1 times 15 and 3 times 5. Do we want a sum or a difference? We need a difference, but why? Exactly, because the constant is negative 15. We need a difference of 17. Let's start looking. 1 times 1 is 1. 4 times 15 is 60. 60 minus 1 is too large. 1 times 15 is 15. 4 times 1 is 4. And the difference of 15 and 4 is 11. So we're close, but not quite there. 2 times 1 is 2. 2 times 15 is 30. And the difference of 30 and 2 is also too large. We now know that the 1 and the 15 are not going to be used. Moving along, 1 times 3 is 3, 4 times 5 is 20, and the difference of 20 and 3 is 17, so that is the combination that we want. Don't forget to keep the GCF of 3 in the front as we draw 2 sets of parentheses to fill in. We use the factors of a to write the coefficients of x, so we have 1x and 4x. In which set of parentheses should we write the constant 3? Exactly! In the one with 4x, because we want the 3 and the 1x to be in different sets of parentheses. We want the 4 and 5 to multiply, so they are also not in the same set of parentheses. Notice how we've drawn the connecting lines here on the left and how they are connecting the same numbers as we have on the right. Now we are ready to put in our operations. Should our signs be the same or different? They'll be different. Why? Because we are looking for a difference. We see that b is positive, so where do we put the plus sign? The product of 4 and 5 is greater than the product of 1 and 3. So the 5 gets the plus sign, and the 3 gets a different operation, a minus sign. Now we have 3 times the quantity of x plus 5 times the quantity of 4x minus 3 as the factored form of our original problem. Looking at our last example, negative 12x squared plus x plus 20, we notice that our a value is negative. What this tells us is that the GCF will also be negative. The GCF is positive when a is positive, and the GCF is negative when a is negative. The GCF of 12, 1, and 20 is 1, and because our a value is negative, the GCF for this polynomial is negative 1. Negative 1 times what would be our original problem? 12x squared minus 1x minus 20. Now we only look inside the parentheses to complete this problem. Pause the video and finish factoring. We know that our signs will be different because our constant was negative. The product of 3x and 5 is 15x. The product of 4 and 4x is 16x. The bigger product has the same sign as b. Again, we're looking inside of the parentheses of our first step, and there, b is negative, so the 16x needs to be negative. Was the 16x caused by the constant of 4 or 5? The 4. So that's why the 4 is negative, and the 5 gets a different sign, a plus sign. Now you have the tools you need to factor a quadratic no matter the value of a. Factoring is the process we always start with when trying to solve quadratics. Great job today!